Okay, so we're asked to solve each of the following and then graph the solution set. So let's go ahead and look at A. So we have the absolute value of 2x minus 1 over 3 less than 5 over 6. Okay, so here we know that this is equivalent to rewriting the statement negative 5 over 6 is less than 2x minus 1 over 3. And 2x minus 1 over 3 is less than 5 over 6. So we could write it as a double inequality. All right, so this is a fraction equation where I would build up each fraction so they have the LCD. Sorry, I misspoke, inequality, fraction inequality. So the LCD would be 6 here. So I multiply the first fraction by 1 and the second fraction by 2. Okay, and the last one here by 1 as well, because those ones already have 6 in the denominator. Okay, so then what do I get next? I get negative 5 over 6 less than 4x, right? Because 2 times 2x there gives us 4x, and then 2 times negative 1 there gives us a negative 2. And then this is all over 6. Less than 5 over 6. Okay, so now I basically forget about the denominators to get negative 5 is less than 4x minus 2 less than 5. In other words, what you're doing there is just multiplying through by the LCD. All right, now I'm going to isolate the x in the middle of these two inequalities here. So I'm going to add 2 on all 3 sides, I guess. So now on the left side, we get a negative 3 less than 4x, because the middle here we added 2 as well. And then on the right side, we added 2, so we get less than 7 there. All right, and now we just divide by positive 4. And that's going to give us negative 3/4 is less than x, and x is less than 7 over 4. All right, so in set builder notation, that would be the set of x such that x falls between those numbers. So in other words, x such that negative 3/4 is less than x, and x is less than 7/4. Or in interval notation, parentheses, negative 3/4, comma, 7/4, closing parentheses. And if we were to graph this, we would have, say, negative 1, or it's negative 2, negative 1, 0, 1, 2, for instance. And then we would have open circles at negative 3/4. Negative 3/4 would be closer to negative 1 than it is to 0. And then 7/4 would be 1 and 3/4. So that would be closer to 1 than it is to 0. And I made a mistake by plotting, by drawing them with solid circles. They should be open circles because we have an open interval. So negative 3/4. Right, negative 3/4. And then 7/4, which would be closer to, 7/4. Think of it as a mixed number. I think I made a mistake earlier. That would have been 1 and 3/4. So it's closer to 1 than it is to 2. And so we'd have an open circle at 7/4. And then shade everything in between. Okay, so that's how you solve that inequality. All right, the next one here, we have 2x minus, oops, let me do that. So the next one here, we have 2x minus 4 less than or equal to negative 5. And then C here, I'm going to write that down. That's 3 minus x greater than negative 5. All right, so the absolute value of x minus 4, if you recall, absolute value means distance, how far you're away. So distance is usually considered positive. And so we're saying is a positive number here, right? This absolute value is always positive. Right? The absolute value of 2x minus 4, regardless of what's in the absolute value, the outcome is always positive. Therefore, a positive number is never going to be less than or equal to negative 5. So in this particular action, there's no real solution. There's no solution. and therefore there's no graph, right? It's just an empty graph. But see here, we have the absolute value of 3 minus x greater than negative 5. Now, for the same reason, the absolute value of 3x minus 5 is always positive, regardless of what's inside the 3 minus x, but in the enclosed in the not the parentheses, but enclosed by the absolute value. So the outcome of that would always be positive. Therefore, a positive number is always going to be greater than negative 5, right? By definition, a positive number is to the right of 0. And so if negative 5 is over here, then any positive number is always going to be bigger than negative 5. Therefore, this solution set is all real numbers. And in interval notation, you would express that as negative infinity to positive infinity. To convince yourself, just plug in any real number you want for x, and then see that the outcome is always positive, and it will always be greater than negative 5.